Hey, welcome back everybody. Jeff Frick here, coming to you from the Humanoids Summit 2024. It's the first one of these shows. I've been told it's the largest collection of humanoid robots on the face of the planet. I don't know if that's true or not. I'm sure I'll get fact checked, but that's what I've been told, and we're excited to be here for the first one. And this next guest has been doing this since 2015, and we're excited to see what he has. He's the only guy that's used the word bionic, I think, since I've been here, which, let's give a shout out to Steve Austin. Before we shout out Steve Austin, we'll shout out Aadeel Akhtar. He is the CEO and founder of Psyonic. Aadeel, great to see you.
Great. Thank you for having me here.
Absolutely. So Bionic, Steve Austin, so what do you got for us? You don't have a whole robot, you've got the hardest part of the whole thing.
We've got the hand, yeah.
The hand. So show us the hand.
Yeah, so I've got the Psyonic ability hand here. So I'm the CEO and founder of Psyonic. We develop advanced bionic limbs that are accessible for humans and robots. And this is our bionic ability hand. It's our first product. And it's all 5 fingers flex and extend, and the thumb rotates as well. Would you like to shake hands with a bionic hand? Nice to meet you.
Amazing.
And so what's really interesting about this is that it first started off as a prosthetic hand. So it's covered by Medicare, it's FDA registered in the US. We've got over 200 patients using it across the US. And we started just in the last, I would say, 2 years, really targeting the robotics community, because it turns out if you're building a robot to do human tasks, we've optimized our hand for humans to do human tasks, so it makes sense to use the same thing.
Right, so you've been at it for 2015, you said before we turn on the cameras, that's the 9th generation.
This is the 9th generation of the hand.
That you've built.
Yes.
So one of the big themes here over the show, because a lot of the context is coming from the industrial world, is safety.
Yeah.
And also with large language models and foundation learning, we know what happens when ChatGPT has hallucination. It's probably not so good if you tell a robot to, empty the groceries and it starts smashing things around the kitchen. Clearly, if you were targeted as a prosthetic at the beginning and engaging with people directly, you've had to deal with that safety issue from day one. So what are some of the things you think about with safety with this thing? It's mechanical, it's got motors, I assume it's pretty strong. How did you start to think about and bake in safety in your design?
Yeah, and so in terms of safety, robustness is really important, right? Because the thing is that in those, kind of those rogue moments where you accidentally hit it against something, right? You want to make sure that it doesn't break, because that's when safety really is critical, right? Because if something is broken, you're still trying to operate it, then it might not work over the object that you're trying to manipulate, right?
Or I'm thinking the other way, you squeeze my hand and squeeze a little bit too hard.
Exactly, right? And so it works in both of those contexts.
Right.
So for us, robustness and compliance was really important in that front. So if you look at this hand, right, if I squeeze these fingers together, they're actually flexible, right? And so when we're doing something like shaking your hand, for example, the fingers are taking the shape of your hand so that it's conforming to that object very much like a natural hand would too. And so that keeps it from really, really squeezing very hard on it. The other thing is that this is the first bionic hand on the market to give users touch feedback. So if you hold the bottom of this, do you feel that vibration coming through? Mm-hmm. So there's a pressure sensor on the fingertip, the finger pad, 2 on the outside and 2 on the inside of the finger, and we can put them in all the fingers as well too. And that way our users know when they've come into contact with an object, and they can keep them from crushing their hand. So first patient in the US was an Army sergeant, Sergeant Garrett Anderson. He lost his hand in Iraq in 2005 due to a roadside bomb. And he told us that he could actually feel his daughter's hand with the touch sensing that was in here, and he couldn't do that with any other prosthetic hand because he was worried about crushing their hands.
Right.
That was really important for us. And also, because the fingers are compliant, I can take this, I can smash it, and it's totally fine. It survives the impact.
Don't smash it.
We've done flaming board breaking with it. I've climbed the roof of my house, dropped it 30 feet in the air. We put it in a dryer for 10 minutes. I've arm wrestled the para-triathlete national champion and lost, so this thing can take quite a beating.
Wow. So talk about some of the development challenges as you've gone through these iterations. Kind of where did you start, and what were some of the really key challenges that you had to overcome throughout the process? Yeah,
so this is, as you were mentioning earlier, this is the 9th generation of this hand, right, since 2015. And when we first started out, everything was completely 3D printed, and we were like, we're going to make this 3D printed hand that's going to be super low cost, and it's going to change the world. And then when we actually started talking with patients and roboticists and all these potential customers, the number one thing they complained about was their hands breaking all the time.
Really?
Yeah. So, and the human side, it was because they would accidentally hit their hand against the side of a table or a door, and the fingers, because they were rigid, they would just snap at the joints. On the robotic side, a robot falls, and then there goes everything there, right? And so, if we gave them something 3D printed, that would break within like a day, less than a day of using it. So we had to figure out how could we leverage the low cost of 3D printing while still making this hand more robust than anything else that's out there. And we came across this field called soft robotics. And in soft robotics, instead of making the fingers and the joints and everything out of rigid components like steel or machined metal or plastic, we would use a 3D printed mold and inject silicone and rubber into it and make it flexible like your own natural fingers are. And so that's why this thing is able to take such a beating. The other thing is stuffing all the motors inside of here. It's kind of a hard feat to do too. So it's gone through many, many iterations over the last like 9 to 10 years now to get to this point.
And then what are as a prosthetic, what are the keys to control? Both control as well as feedback.
Yeah, so if it's on a human, so this, I'll show you, this is the hand itself right over here, right? You can hold it yourself too. So if we're going to go on a human, if I was missing my hand, I would have a socket that's made. So it's kind of like if you broke your arm and you get a cast made. Okay. Imagine getting that cast made of your residual limb. You put your arm inside that cast, which we call a socket, and then we have the muscle sensors and batteries embedded on the outside of that, and the hand will attach at the end. And so just by using your muscles, you can actually control all the different grips that are pre-programmed into the hand.
And do you have to customize it for the muscles that are available inside of the of the amputee?
Exactly. And we work with clinicians in order to make that custom fit for them. So we'll sell the hand to the clinicians, and then clinicians will do all the fitting and then bill insurance for it.
And what's the variability that you have as control as an amputee for what you can do with the, once you're good and you're trained and you really got it down?
Our users have done all sorts of activities, like basically every activity of daily living you can think of, from like tying your shoelaces, which is always impressive in my, like one of our users, she's our user experience specialist, Annika Berlin at Psyonic. She can tie her shoelaces faster with her bionic hand than I think I can tie my shoelaces with both of my natural hands. So the first time I saw that, I was just floored, right? But like things like just everyday tasks from like carrying your groceries to like washing dishes, but also like we've taken it to the gym, we've done weightlifting with it, we've played golf with it, we've gone paragliding with it, our users have gone paragliding as well too. And so, and if it can do all those tasks, if you're trying to get a robot to do things like cleaning up the house or things like that, if our users can do it, the hand should be able to do it, the robot should be able to do it too.
Yeah, because I would imagine that the inputs are much less specific, much more subtle for somebody wearing a prosthetic versus having an API and some control algorithm.
Sure, and so we built the hand to work with clinically available like systems now, like those 2 muscle sensors, but also we moved to San Diego 2 years ago, and one of the big reasons why we moved there is that we're working very closely with the Navy Hospital and the University of California, San Diego. And so I'm affiliate faculty at UCSD, but we're working with an orthopedic surgeon at the Navy to directly connect this hand to your bones with a titanium implant. And then with UCSD, we're working with a hand surgeon to place fine microwire electrodes through your nerves directly, and then that would actually get you individual finger control. So actually, we're going to do something fun here. Okay. And just to demonstrate what that would kind of be like, we're going to have you control this hand. And so I've got this, I've got my phone here with an app connected, and there's Bluetooth in there. There's an app for everything these days, right? So if I've connected everything properly,
right? 30%, right?
So if I've connected everything properly, if you put your hand in front of the camera, so go ahead and just put your hand in front of the camera right there. Okay. Yep, and then bend your fingers.
My hand.
So yeah, you're controlling each individual finger on here.
Hook 'em horn, right?
Yeah, there you go.
Very cool. All right. So what's the idea there?
So instead of using the camera, you can imagine using nerve inputs instead, right? So then this will become a training tool for our human users to then train the machine learning algorithms to then learn what your nerves are trying to do. But also, like NASA is using our hand, they've got it on their humanoid astronaut robot Valkyrie, and they're doing teleoperation of it, right? So you can imagine that the hand is like halfway across the world or even up in space, and then you can be sitting in front of a screen and then teleoperating it that way as well too.
So from a business point of view, do you see that as being, kind of your new focus? I would imagine the business opportunity from your investors are saying, Aadeel, that's a much bigger TAM, or is that going to defocus you? How does that fit with supplying them for robotics manufacturers, but also continuing on your initial mission?
The beauty of it is The only difference between our human hand and our robot hand is the wrist connector, because it just needs to fit onto a robot arm instead. It is the exact same hand that goes on the humans that goes on the robots.
So you've got some type of interface between the computer controller and then you add that extra layer for the person.
Exactly.
For the direct person control.
Exactly, and so we have an API that allows any of our researchers to control the position, velocity, and torque over all the motors. You can stream all the touch sensing back over Bluetooth, over a USB connection if you want as well too. And we're seeing our researchers on both the clinical side doing like brain implants and nerve implants, as well as the robotic side using that API to integrate it into like their robots. So for example, Aptronic is one of our the users on the robotics side, and they have a deal with Mercedes, and they've got videos of Mercedes putting cars together with our hands. And again, I can pop that hand off and put it on a human, and they'd be able to operate it using their muscles.
Now, how did you get started? Why did you pick this project?
Yeah, so I wanted to build bionic limbs my entire life, ever since I was 7.
Did you have a family member, or did, there must have been some motivation behind that?
Yeah, so my parents are from Pakistan. I was born in Chicago, but I was visiting Pakistan when I was 7, and that was the first time I met someone missing a limb, and she was living in poverty in the streets. I didn't know her, but she was missing her right leg and using a tree branch as a crutch, and that's what
tree
inspired.
branch.
Yeah, and that's what inspired me to go into this field. So yeah.
You picked the hardest part of it. You didn't do legs, you went right for the
Yeah, we went right for the hands. we do have plans to make legs though too.
That is great. So a little bit about kind of some of the changes that we're seeing in the industry. A lot of talk here in terms of what ChatGPT and large language models and foundational models have opened up in terms of the way these things are trained and the way you increase capability. The other piece that we see all the time in tech is the exponential curves and motors and material science and compute power and all this stuff. How are those two things impacting, kind of your growth trajectory and your development trajectory?
Yeah, I mean, we're seeing the volumes on the robotics side just going up massively. And it has a lot to do with, these foundation models, these large language models as well too. I mean, so actually just yesterday, Google released a video about Gemini, like the Gemini 2.0 coming out. And in that video, you can see them using our hands to do like high-level commands. So it's just like, go and pick up that thing off the table, right? And so like it'll go and pick up like this water cup off the table like I just did. I'm a human controller, but you can give a high-level.
How did you control it to pick up the cup?
Oh, so I'm using these 2 buttons right over here. Yeah. So and
what do your buttons do? What do the 2 buttons do?
So they open and close the hand, right? So I can open
close.
and close the hand this way, and I can switch between different grips, so I can do like a pinch. If I'm at a rock concert, I can like rock on.
Right, right. I saw on the website you've got all kinds of expressions that you can pre-program into it to do different things.
Yeah, and we can make the finger wave as well too. So.
and then the big I don't know, IP probably is in the sensors and the way that it didn't squish that cup.
Yep.
Just a regular paper cup, it's not like a fancy cup.
Exactly, and I could feel from the vibration, like when I was making contact and how much force I was applying.
Did you stop the squeeze, or did it stop on its own?
No, I stopped the squeeze. But we could program it to stop on its own as well, and that's the beauty of things like the large language models that you're talking about, is that you can program the AI to like know that if I'm applying this much pressure to the hand, right, then I can like make it stop so it doesn't like crush it, for example.
Right,
yeah.
right.
Yeah.
Very interesting. So you're on Shark Tank. I have to ask you, how was your Shark Tank experience?
It was nerve-wracking and exciting at the same time.
Did you get funded? Did they give you money?
So we got 3 sharks to come in on that deal. So it was Kevin, Laurie, and Damon for $1 million. And right now it's still under negotiation. But yeah, it was definitely exciting to be on the show.
So while we're on it, then, so give us a little bit on the company. You said you founded in 2015. How many people are you? How many rounds of funding have you gone through that you want to talk about? Where are you kind of on the company stage?
Yeah, so we founded in 2015. We moved to San Diego 2 years ago, and when we moved there was only 7 of us, and now there's about 30 of us. And just last week we closed on our new building, and it's like 4.5 times bigger than our current space that we have right now. So we're in the middle of scale up like right now, which is just such an exciting time for us. And yeah, it's been really great on that front. On the funding side, so we raised like a pre-seed round like maybe 4 years ago or so from angel investors, and that was like 1.4 million that we raised on that. And then at the beginning of this year, we closed on our seed round where we raised 4.1 million, and that was from equity crowdfunding actually. And it was interesting going that route too, because a lot of our outreach is through social media, and so we had this whole body of content. I mentioned some of the things like dropping the hand from the roof of my house, arm wrestling, the triathlete national champion, and so we were like, this doubles as like marketing to put it on inequity crowdfunding. But even more importantly, the most beautiful thing was that we're a company that's all about accessibility, right? Accessibility about like our products. And so why don't we make the company itself accessible? And our own users have now invested in the company. And how beautiful is that? We make this for them and they get to be a part of the thing that's being made for them.
And how capital efficient, my goodness, you've only raised like 6-7 million total?
Yeah.
You got that?
Yeah, we run really lean. We run really lean.
So what's next in 2025? What's kind of the next big hurdle to get over?
Yeah. So we're always looking to see how much more we can squeeze inside of here. So we're going to look at sensorizing like the palm as well too, so it can feel on the palm. Maybe even adding in like a finger spreading as well too. But we're always looking into like wrists and elbows as well as knees and ankles too.
So right now it's predominantly the fingers then?
Yes.
Yeah.
Yes,
So wrist would make sense.
Yep.
Very exciting story, Aadeel. I love it. I love the enthusiasm.
Thank you.
I love the kind of the modern funding. I mean, you see that in a lot of skateboards and a lot of kind of crowdsourced things, and some of which turn out to be really, really good. And so how great to go directly to the community and be a little innovative in your fundraising as well.
Yeah, and honestly, it's been a blessing. It's been a blessing.
Great. Well, Aadeel, great story, and love the. I got to give one more shake.
Yes, all right, let's do it.
All right, very good. All right, he's Aadeel. I'm Jeff. You're watching Humanoids Summit. Thanks for watching. We'll see you next time.